This video is going to introduce Chapter 8 of the Building Java Programs book about classes. And this is a very different topic than everything we've done so far. Everything we've done so far has been focused on figuring out how to program, how to write a program based on what we call procedural programming. And procedural programming means we figure out what are the functions that we need to do in order to make our program work. To provide some motivation on why we should care about object-oriented programming, I want to give you an example. So let's suppose we're designing a blackjack game. So I think you understand how blackjack works. You've got a deck of cards, 52 cards with the standard four faces and all the values, and you want to try to get as close as you can to 21. So in order to create a program for that game, you're probably going to do something that looks like this. You're probably going to come up with an array of 52 cards. And in order to do that, you're probably going to actually need two arrays. One array is going to hold the value, the face value, like 5 here, or king here. And the other array is probably going to hold which suit it is. So is it a heart, a diamond, a spade, clover? And then we're going to write a main program. And that main program is going to understand how to play blackjack. So it's going to know that we're probably going to start by shuffling that deck, and we'll have to write a procedure to shuffle that deck. And then we'll probably have to have a loop going through however many cards, and we'll need to be able to deal the top deck card. We're going to follow all the rules of blackjack, put down a couple of cards. I'm not an expert in blackjack myself, but we're going to have to write procedures to do all these things. So that's procedural design. And there's nothing wrong with procedural design. It's worked for a long time. The problem really comes in when we want to look at doing something else. So let's suppose that after making a very successful blackjack game, we want to make some other games. So suppose we want to write an Uno, a kid's game, or Old Maid, another kid's game. So we've got some challenges ahead of us because in Uno we have these colors instead of suits. We have special cards like this one here. I think lets you change the color. There's actually 108 cards in a deck. So we're going to have to go back and at least change that number. And we'll have to figure out, we might be able to shoehorn the colors and the special values into the cards that we already have, but I'm not so sure. Old Maid just has pictures. And there are a variable number of cards depending on how many pictures you want to have, but there's always an odd number of cards. So again, this is going to be tough to put into our two arrays that we looked at doing. We might be able to figure out a way, and this is the way that programming's been done for a long way. You try to be clever about trying to reuse your code. They both have similar shuffling algorithms, but the gameplay is totally different. In blackjack, we're always trying to come up with 21. In Uno, the rules are different. You're just trying to match. In Old Maid, you're trying to match. So we have to think long and hard how we're going to do this. We probably might just throw away the code we have and start from scratch. Otherwise, we'd have to maybe add a third array that could handle colors or special values. Maybe have another array that would handle images or something like that. So we have to completely redesign our procedures, and what's worse is that the code that we use to, say, shuffle the cards is probably likely entirely dependent upon the data structures. So, for example, the shuffle algorithm here probably knows that there's these two arrays, and that it has to go in, and there's 52 values, and it's going to go in, it's going to swap all these out, and when we try to apply that to this Uno game, if we have a different array, then we're going to need to modify the shuffle algorithm, at least the code, in order to be able to shuffle this deck differently. So really, in order to be able to do any changes, we have to read all the code in order to be able to safely modify anything. And this is the kind of problems that we've dealt with for decades in programming with regular procedural programming. So the solution is object-oriented programming. Let's talk about some definitions of object-oriented programming. So whereas procedural programming was thinking about what procedures we need to write, object-oriented programming is really reasoning about a program as a set of objects rather than those actions. An object, we've already seen several objects. We've seen the string object, for example, and these objects contain state and behavior. So in the case of string, the state or data is the string. So if we create string s equals hello, then that state or data is the set of characters HELLO, and the behavior, well, we've got we've got index of, we've got dot equals, we've got a whole bunch of string methods that we've learned. We've got dot substring. So those are the methods. So we've talked about the data already. Behaviors. So in addition to those ones that we've talked about for string, in general, for an object, you have to have some way of creating a string. Okay, and then you also need a way to get the state, and you need a way to set the state. Those are the three general categories. Some people call them methods, some people call them functions, some people call them interfaces, but it's collectively the behavior. And one of the advantages of object-oriented programming is what we call data encapsulation. So we encapsulate inside this object, we encapsulate the state and behavior versus the blackjack way where we were going to do it procedurally. That those two arrays are not at all encapsulated. They're not hidden in any way. All of the code knows what all of the data is, and whenever you change any of the data, you have to go into all the places that touches the code. So encapsulation allows you to be able to hide things, especially from the outside. So let's talk more about the example of object-oriented programming with the blackjack. So again, object-oriented programming is to approach the problem as objects instead of procedures. So let's think about blackjack. What are the objects involved in blackjack? An obvious one is the card. So for a card, what is the state or data that goes with a card? So like string, we had the letters that are going to go into that string. For a card, you probably need some sort of a value, and you probably need some sort of a type. Maybe for Uno, you would need some sort of a bitmap item, or maybe you'd have a string that identifies a bitmap or something. And then for behavior, I mentioned there are three general types. So there's a constructor. So you have to be able to construct a card. It would probably take a value and a type. So you could create an ace of spades. And then you have to have a way of getting the card and setting the card. So that's one object. And then we have another object we need to think about, which is a deck of cards. So a blackjack deck has 52 cards. Uno deck has 108 cards. So when you have a constructor for this deck, it needs to know probably how many cards are going to be in that deck when it constructs it. And in addition to the general ways of accessing the card members, so you want the top card, you want the bottom card, whatever, you also want to be able to have some special methods on it, like dealing and shuffling. So this is a way of how we would break up the blackjack problem into objects. So some of the advantages of doing a blackjack game object-oriented is that you can change the implementation of the card or the deck without affecting the client. So when we go in, we decide we want to change from having a blackjack deck to an Uno deck, we can create a new type of card, and it can still be used by any client, whether that be blackjack or Uno. And there's code reuse. So for example, if we write shuffle for blackjack, it's probably going to work just fine without any modifications. If we create the Uno game, it'll just use the same shuffle feature, because card is generic. It doesn't matter whether it's an Uno card or it's a blackjack card. And more than that, we can provide any new features that we create for our card deck to other games. One huge advantage of object-oriented programming is maintenance. Oftentimes we spend more time maintaining code than we do writing code. And it's a lot easier for someone to understand and learn if they see there's very simple defined objects. Oh, it's like, oh yeah, there's a card object, there's a deck object. Pretty easy to understand. They know that if they're in charge of rewriting the shuffle algorithm, they know where to find that. They go down here and shuffle. And they don't have to worry about, gee, what are all the data types involved in the card, because that's a whole separate object. Just a real quick view of an implementation. So we've already seen that this public class type of thing, but we've never really created a real object. And when I say a real object, I mean something with either private or public data in it, okay? And then there are methods that are defined on this object. This is a constructor, and this is an accessor, and this is a mutator. Here's another class. This would actually have to be defined in a separate file, but you've got the deck class, and it's got the state, and then it's got the constructor and the accessor and shuffle. So just a quick review of what we've learned so far. So procedural programming is we decide what procedures we're gonna need to make the program work. Object-oriented programming, we decide what objects needed to make it work. The objects consist of both state and behavior, and the behavior has three general classes. You have to be able to construct the object, you have to be able to get the data out of it, and you have to be able to mutate the data. And the advantages are forced data encapsulation, maintenance, and code reuse. Okay, now I'm actually going to switch decks to a different deck to go do one more of our normal slides. So when we were looking at that class definition, I wanted to emphasize that classes, when we define classes by themselves, that is a blueprint for an object. So an object like the strings that we've been using so far and all the objects you'll be using in the future, those objects are different than classes in that the class is the blueprint for how to create one of those objects. And we'll see a little later on when we actually start creating real Java class definitions. We'll clarify that the code that you see there is not the instance of the object, that it's a blueprint for the object. And that's storing its state and the behavior. We also refer to the client. So the main loop, for example, that creates a new string, that's the client. So now we're going to talk about a more concrete example. There's actually a class in Java called the point class. And so we're going to take a look at how we use the point class, and then we're going to actually implement a point class on our own so you can see how that works. So the point class is part of the Java AWT package, and it has as its state x and y coordinates. And you can call a constructor with a specific x and y just like this. Just like we would do for a string, we say point p equals new point, and then we pass in this data. And what that does is it creates a new object with p pointing to this object that has the data here, 3 and 8. So just like the string class has methods, the point class has some methods. You can translate, so in other words, you can move that point by some amount in the x and the y axis. You can set the location at a specific xy axis, and you can compute the distance from another point. And we've already learned that, for example, with strings, you can do string.indexOf. So here we can translate, and we can also access the x and y values directly out of the point class, like sum equals px plus p.y. So now we're going to take a look at some client code, and I'm actually going to go to Eclipse here to show you that. Here's that client code in Eclipse, and we'll actually go through and debug this here. I'm going to step into this code using, we'll start debugging, and then I'm going to step, well, so let's step over this with F6 and then actually bring up the debugging window so we can take a look at P. So here's P. I just created P as 0.38. If I open this up here, we can see those values there. And then let's try stepping down into the next line. It's going to actually translate -1, -2. So that's going to adjust the x and the y. -1 in the x direction, so that should come out 2. -2 in the y direction, 8. So it should be, or 6. So it should be 2, 6. There it is. Okay, and then we're going to print that out. And notice down here that it's printing this nice format, point x equals 2, y equals 6. And again, what we're using now is the Java class that's provided by Java. Okay, so p.x equals 5, so we just changed that from x equals 2 to x equals 5, and then we're going to print that out at the end. Okay, so that's using the Java class. So we don't have to use the Java class that we can import. Instead, we can actually create our own class, and we're going to do that in just a second. So remember, what do we need for objects? It has state and it has methods. So for the state, we're going to create a field for the x and the y, and we're also going to create some methods. And this again is what we call encapsulation. We're going to hide the implementation details. There's two definitions here. You know, these definitions are kind of confusing. I'm not going to worry too much about them. So the way that we create the fields is with this syntax. So the private here is optional. So if we do private int x, then we can no longer access x from outside and y from outside. So if we don't put private here, then it makes it available for everyone to see. So let me go back to Eclipse and show you what I mean. So here's that same code in Eclipse, but this time I've added a point class. So we've got public class point, just like we've declared classes in the past, but now I've got this int x and int y, and you notice I have not yet put the private on there, and that's because I want to be compatible with the existing Java class, just to show you. So this is what we call a constructor. So the constructor creates a new point, and the format is public because you want people to be able to access it from outside your class. So now we're finally understanding what all this public static void stuff means. And then normally you would think of the constructor as having a void here, but that is actually a serious bug. Constructors are defined as not having any return value at all, not even void. If you put void here, this is actually not going to be a constructor. This is just then some method on the point class called point. So that's an important bug to avoid. So don't put void there. So point takes two variables, initial x and initial y, and it sets the x and the y. Okay, and these by default are going to be 0 initialized. So whenever you have object fields, they're going to be 0 initialized, just like an array is 0 initialized. So when I say over here new .38, this code should actually be called. Let's ignore this one for a minute, but we've got translate down here. So this is a method now, or mutator, and translate takes an x and a y, and we set the location x plus dx, y plus dx. So this x right here, you notice that x is not declared, it's not in the arguments, and there's no local x here. In fact, this is a bug. If you put int x here, that x is not the same as the class int x. In fact, I wouldn't be surprised if this is complaining about that. Yeah, the local variable x may not have been initialized. No, that's just local initialization. But this is going to be different. This is actually going to create a new x variable, okay? And that is not the same as the x that the class uses up here. So don't redefine your variable. Maybe we'll try experiment later. And then set location here. So this is this type of mutator. We can call it a setter. Sometimes we have getters and setters, but it takes these two parameters here and then it sets the x and the y to those values. So what I want to do is actually debug this and see what happens now. So let me go into debugging. So let's debug. Okay, so then let's step one more line. Okay, so now we've got P, and similar to before, actually what I should have done is step into that, but let's go do the next one here. Let's step into this. Perfect. Okay, so this actually brought us to our own class here. So you can see that it's actually calling. Oh, this is a great time to see what this is. So there's what's called an implicit parameter. The truth is that when we call point, well, let's go back here and see what the code actually was. The code was p.translate. When we call p.translate, it actually, what it does is it calls a function with these arguments, but there's a third argument that's not actually shown anywhere. And that argument is referred to as this, okay? So that's the implicit parameter. I'll show you in a minute how we can use this. But then there is dx and dy. That's the two arguments that are passed in. Notice that there's no x shown here. Let's see what happens when I look into this, though. This actually shows us is the object that we created previously with the x and the y. So let's go ahead and step into this again. This should bring us to the set location. Set location has the new values of 2 and 6. Okay, and let's take a look at the this. So this is the 3 and 8 that it used to be. And watch what happens when I step over this next line. It's going to set the x and it's going to set the y. Okay, so now we've changed those values. Now it's going to return back to translate, and now it's going to return back to the main routine here. But now take a look at p. Okay, p is now modified. Okay, and let's see, do we have another code? No, we don't have any more code, but we're going to go ahead and step through this. Similarly, p.x becomes 5, and oh, do take a look at this though. Notice what's printing out here. What was printing out before was this nice printout that showed us what the x and the y variables are, and instead we see this, which is actually a memory address. And why is that? That's because we never bothered to write a special function. So let's go back out of debugging mode to our coding mode, and let's write that special function. That special function is called, that's the wrong place to do it, here, toString. Any object that you create, if you don't create a toString method, actually it's not a void, it's a string, what you will get by default is the memory address when it tries to print it out. So instead, what we want to do is we want to return, and then we want to print out, let's see, the open bracket plus x plus comma, we won't do a space, plus y, and then close brackets. Okay, so now when we call println, it should actually print the right things. Let's see. I just got to put a plus there. Okay, so now let's try this again. So let's run debug. Okay, so we're about to call the new point. We'll do the F5 step into, and perfect. It dropped us into our own creator here. So let's take a look at this. This is defined initially as 0, 0. As I said, all objects are created initially as 0, 0, but now the constructor is being called. So as I step over this, it's going to set the 3 and the 8. And then we're going to come back out here. Now let's see what happens when I do this system out println. Actually, let's step into and see the toString function was called. And so, fortunately, we can't really see that operation. So we'll just go ahead and it's saying, hey, I don't have the source for that, which is fine. Oh, darn it, can't. Okay, finally it came back. So now it says P is initially 3, 8. So it worked. Let's go ahead and let's just continue on through the rest of this. So we fixed that. Now I said I was going to show you what is the difference. What's the deal with this? Okay, so let's go over here. Now, let's take this. So you notice I used this variable initial x, you don't actually have to use initial x. We could have used x and y. But the problem is, if I replace this with x and this with y, the question is now, which x and which y am I referring to here? We've got an x and a y here, so this is your object's data, x and y, and this is the parameter, x and y. And that's rather confusing. So to avoid that confusion, what you can do is set this dot x and this dot y. So remember in the debugger where I was showing what this is? So you can literally use that right here, this dot x and this dot y. This refers to the current object. And this gets a little bit circular in logic, okay? So remember, this class that we're looking at right here, this is the blueprint, okay? This is the blueprint for a point object. But sometimes inside the blueprint for a point object, you need to refer to not the blueprint, but the actual instance of the variable. And that's what this is, okay? I know, that's confusing, isn't it? Once you get used to it, you'll understand it better. So anyways, I just wanted to show you can use this dot x and this dot y, and what that does is it means these guys up here, not these guys here. These are what we call the formals to the parameter. And there are people who would say you just never want to use the names, the same names as you use for the private data, but I just wanted to show you that's possible. So next I wanted to talk about encapsulation. So by not putting anything here, not putting private, these were automatically public. And by doing that, that allows us to access this here. I want to show you what happens now. First of all, why do you want to change this? Java provided the point class with x and y being public, meaning anybody can go ahead and access, can either read or write the x or the y values. Why do they do that? Because it's a lot quicker and easier to do it that way. And they weren't too worried about people going in and modifying x or y. There are other cases where that's a much more serious problem because you're trying to hide the implementation. But let me just show you. If I make this private, what happens? Let's go back here and let's try running this. Okay, so already before I even compiled it, it's already throwing an error. The field point.x is not visible. So as soon as I made it private, that makes sense, it's no longer visible. Outside the class, you can no longer access the x. So how are we going to do this? The way you're going to do this is you're going to have to create a new type of method called an accessor. And here, let me just paste in this code here. So you can see this is a little bit of a waste of code because all this thing is doing is returning the member variable. Okay, we call these getters, and you may see in Eclipse some terminology of getters and setters. So these are the getters. So now when I'm over here, I can do p dot. Oh, actually, I can't. This is actually setting. Hold on a second. I'm going to write this and then go and do it. Okay, so we also need the setters in here. Public void set x, and then this dot x equals x. I actually gotta change this to be int x, and public void set y, and just to be different, I'll show you int new y, and then I can say y equals new y. Okay, so boom, it went away. So now we can compile this, and it runs. And notice if I wanted to get x, I would have had to do p.getX. Okay, so that's what happens when I make things private. So why do you want to make things private? Well, suppose I don't want to allow people to just set the x. I really wanted to set both the x and the y because it's not clear that I know what I'm doing if I just set one. Then I could get rid of the set x, y, and I think that there's a set location. Just require them to use set location because maybe there is some constriction on the data such that, for example, the x and the y have to be within some certain range of each other. Then you wouldn't want people just willy-nilly modifying x or y on their own. This here could then actually put some code in here to make sure are x and y within a certain range of each other. Okay, so that's an example. All right, so we've talked about that. Another thing I want to talk about is multiple constructors. We've already talked about overloading. So right now we can only construct a point by passing in an x and a y. By default, before you do anything, you actually get a constructor that looks like this, where x equals 0 and y equals 0. As soon as you define one, then the default one goes away. So if we want to restore it, we're going to have to put it in here. So now what I can do is I can say point q equals new point. And then let's do this for q. And let's try running that. So q, there we go, gets 0, 0. And just to show you that there's no tricks up my sleeve, we could set this to 1, 1. And try running that. And now it's 1, 1. Okay, so you can have as many constructors as you want. In this case, we had no arguments. We had x, y. I could have easily created a constructor with a string, maybe a 2-digit string where the x value is the first character of the string and the y is the second character of the string. You can have as many overloaded constructors as you want. Just remember, you can't have any returns in them. So I haven't been using the slides, but we are actually done. I've actually covered everything that's in the slides, but I want to just summarize by looking at our code. So objects consist of two things. They consist of state, which is data, okay, in this case, x and a y. And then we have methods, which consist of three general types: constructors, accessors, okay, and then mutators. Sometimes they're just simple setters. Sometimes they are more complicated things like this one down here. And your data can be public if you don't do these here. But if you do that, then you take the risk that somebody's going to come in and modify your variables without doing proper checks. Okay, and that may not be good. So in general, whenever possible, you should make your data private. You can have multiple constructors. And in any of these methods, constructors or accessors, anything, you can use this if you want to use the same variable names for arguments. This whole thing here, this class definition, so notice that there's no main in here, right? Okay, so when there's a class definition without any main, this is just a blueprint, okay? This is just a blueprint. Over here, this is an object. So some people ask, you know, when you call this constructor here, doesn't it need to know about P or Q? And the answer is no, it doesn't need to know anything about these. When you call P or Q, what it constructs based on this line here is it constructs a little piece of memory that holds your private data and a pointer to all of these routines. But basically you can imagine that what it constructs is something that has your private data and this list of methods, okay? All the methods that you can call on it, okay? And then you can access those methods. Here we got p.translate. So that's pretty much what you need to know for objects. So when you're going to create your own object, you got to figure out what is the state of your object, and do you want it to be private or public? Okay, and you need to create constructors for your objects. You need to create, if it's private, you need to create accessors, gets and sets, and then you probably want to create some other behaviors on your objects. Okay, so that's what you need to know. Thank you very much.